Have you ever stared at a long string of ones and zeros and just your eyes glaze over? It looks like an alien language, right? Well, today we're going to learn a super simple trick to translate that into something way more manageable. We're going to crack the code of converting binary to octal. So, let's set the scene. Imagine you've got this secret message, a digital key, and you have to figure out what it says. This is a really fundamental skill in computing, but don't worry, we're about to make it unbelievably simple. And bam, there it is. This is our code, along what looks like a totally random sequence of ones and zeros. I mean, at first glance, that's pretty intimidating, right? It's just a wall of numbers. So, what's your first instinct? Probably to reach for a calculator or start doing some crazy math, right? But what if I told you there's a secret, a little trick that makes reading this thing almost as easy as reading, say, the number 123? That's the question we're going to answer right now. And that brings us to the core of this whole thing. It's not some complicated algorithm. It's actually a really simple, kind of elegant rule. I like to call it the 3-bit secret. Okay, here it is. This is the key to everything. You just take your binary number, and starting from the right, you just chop it up into little groups of 3. That's it, I'm serious. Each of those little 3-digit chunks translates directly to one single digit in octal. We're basically turning one giant and scary problem into a few tiny easy ones. All right, so theory is one thing, but seeing this in action is where it's really going to click for you. So let's put this little secret to the test. We'll run through a couple of quick examples. Okay, let's start with a nice clean one, 10101. It's got 6 digits, which you might have already guessed is just perfect for our 3-bit method. It's going to divide up real nice. So following the rule, we start from the right, we count 1, 2, 3 digits, and boom, draw a line, and look at that. We get 2 perfect little groups, 101 and another 101. Couldn't be cleaner. Okay, now for the magic trick, the conversion. Just remember this, 4, 2, 1. From left to right, that's the value of each spot. So for our group 101, we have a 4 turned on, the 2 is off, and the 1 is on. What's 4 plus 1? It's 5. And since we have 2 groups of 101, well, that's just 2 5s. And just like that, we did it. That binary number, 101101, is just 55 in octal. See? No crazy math. Once you get the hang of this rule, it's lightning fast. All right, I know what you're thinking. That was too perfect. The number divided neatly by 3. But what happens when it doesn't? What if you have leftovers? Great question. And don't worry, the system has a super simple answer for that too. Okay, let's try this one. 1001. We do the same thing. Start from the right and group the first 3. That gives us 001. But uh-oh, look what's left over on the left side. Just 10. That's only 2 digits, not 3. So what do? The solution is so simple, it's kind of brilliant. We just stick some zeros on the front of that leftover group until it's 3 digits long. It's called padding. And since they're leading zeros, it doesn't change the value at all. So our 10 just becomes 010. Problem solved. And now we just convert like before. Our right group, 001, well, that's easy. That's just 1. And our new padded group, 010, using our 421 rule, that's just a 2. Simple. So you put those 2 digits together, and there's our answer. 1001 in binary is just 21 in octal. See? That padding trick makes this method work for literally any binary number. Doesn't matter how long it is. Okay, now that we've seen all the pieces, let's wrap this up into a quick, repeatable shortcut you can use anytime. This is how you make this whole process feel like second nature. It boils down to just 4 simple steps. Step 1, start from the right. Always. Step 2, group everything in 3s. Step 3, if that last group on the left is a little short, just pad it with zeros. And step 4, convert each little group. That's it. That's the entire playbook. Hey, remember that big, scary number from the beginning? The one that looks like a secret code? Doesn't look so intimidating now, does it? Let's use our new 4-step shortcut and crack this thing once and for all. All right, let's fly through this. Starting from the right, we have 101, that's a 5. Next up, 011, that's a 3. Then another 011, hey, that's another 3. And finally, we're left with just a 1 all by itself. No problem. We pad it with 2 zeros, it becomes 001, which is just 1. And boom. Just like that, the power of this method is crystal clear. That long, confusing string of ones and zeros, it's been totally decoded just by using one simple rule.
And there you have it. 1, 3, 3, 5. Clean, simple, and totally readable. What was once a total mystery is now just a straightforward number. Awesome.
You know, the real takeaway here is that a lot of times, something that looks super complex is really just simplicity in disguise. Just by knowing how to group the information, in this case, into little chunks of 3, we can make total sense of systems that look crazy overwhelming at first. It really makes you wonder, doesn't it? I mean, if this super simple 3-bit pattern is the key that unlocks Octal, what other secrets, what other shortcuts are just hiding in plain sight, right inside the fundamental language of computers?